Our goal over the next two videos is to kind of bring this image to life, in our games, that is, of course. Now we're going to start simple. We're going to start with just basic horizontal movement, moving left to right. So what we're going to do is we are going to create a program where the player can use the arrow keys to move to the right, move to the left, but we're going to apply acceleration to this idea. So we're going to add a force of acceleration. So they are accelerating in a single direction. Okay. Now that being said, what's going to happen here is when we do this, there's going to be an opposing force, a force going against it, which we call friction. Now, you've all heard of friction before. We talked about it in the previous video. And basically what that means is friction always goes in the opposite direction of your movement. Now, there's a lot of different types of friction out there, wind resistance and things like that, but we're not going to deal with that. We're only going to start off very simply and just use ground friction. So basically, think of it like this. If you rolled a baseball across a cement floor, that ball is going to go for a long time because there's not a lot of forces going against it. There's a little bit, but not a lot. But if you rolled that same baseball through a field of grass, it's gonna stop a lot quicker because they have different opposing forces based on the friction applied to them because of the ground surface that they're rolling on. Now, what we're going to do is we're going to apply this to our game. We're going to have a player accelerate based on their movement. So think of it like your legs pumping, and the more you pump, the faster you accelerate. But when you stop running, friction takes over. And friction is going to decelerate us. Now, we are going to do this as simply as possible to demonstrate this, but you realize that it can be applied to a lot of different situations and customized in a lot of different ways as well. So instead of writing the code from scratch, because there's too much to do that and actually explain everything effectively, what we're going to do is we're going to just show you the code, and then I'll explain how it actually works, and then I'll demonstrate it to you. So first up, created a brand new project, and what we're going to do is we're going to have a single image. Let's show it to you first. We're going to have a single image. There's that little spaceship there. It's just sitting on the bottom of the screen. Now, if I hold the right key, you're going to see it accelerate to the right-hand side of the screen. Now, I'm not sure what kind of frame rate we're looking at with this recording software, but it's going to move very smoothly for me at 60 frames per second. And I'm going to let go at about the half screen point, and you're going to see it decelerate, and it's going to kind of slow down to a stopping point. So let's hold it and let go, and it automatically stops. So bring it all the way back to the edge of the screen. I have some collision detection on the edges of the screen to make sure it doesn't leave the screen, but that's not really the point here. So I'm going to hold it and let go at the halfway point. Release. And you can see it slow down fairly quickly. Now think about this in games. Now if I hit left or right, the friction is always going in the opposite direction I'm moving. So if I'm moving left, it's pushing me to the right. If I'm moving right, it's pushing me to the left. Now we have no jumping or anything like that because this is just a basic. Now it also works in the fact that if I'm holding right and I let go, it decelerates fine. Now watch how fast it does it if I instead of just letting go, I hit the left key. So I'm going to let go at the right hand at the middle again. So see where it ends up. Let go. And that's where it ended up. Now, instead of that, I'm going to hit the left key instead of releasing. And you can see it stops a lot faster. And the reason why it stops faster is that my force of movement, so like my legs pumping if I was running, is stronger than the friction. If it wasn't stronger than the friction, then I would stop moving, right? That makes perfect sense. So since it's stronger than the friction, that means if I hit the other way, it's going to slow down a lot faster than if just friction were acting upon it. So let's see how this actually occurred. So we just have a basic image that's moving from left to right or right to left. So let's start off with the simple stuff, which is the image data. So we have the image. We have a rectangle to store its location, its draw position, and then we have a vector 2 to store its true position, because we're definitely going to be moving fractions of a pixel here. As normal, I'm keeping track of the screen dimensions as well as the keyboard state, so I can handle movement and collisions and placement and things like that. But now let's get into the actual code for acceleration. So I've got a series of variables here. First up, instead of using delta time and everything like that, I'm going to try and keep everything as simple as possible. I'm just moving everything based on movements per update. Okay? So in this case, I'm saying the maximum speed my player will ever move is 5 pixels per update. Now I'm keeping track of how fast the player is currently moving. Now the player isn't moving, so it's moving at a speed of 0. Now you'll notice that I'm using a vector 2 to store the player's speed. And the reason I'm doing that is so I can store its horizontal movement, which is its X component, and its vertical movement, which is its Y component. You might be like, but Mr. Lane, you said you're only moving horizontally in this demo. That's true. But in the next demo, we're going to expand upon this and add jumping, and we're going to be able to move vertically at that point. So we're going to try and keep it consistent. So our player's current speed is 0 in both directions. It's not moving at all. So now I've created a few constants. Now you could use variables for this, so that way you could tweak them while the game is playing if you would like. It's completely up to you. I'm using constants just to keep the code simpler here. So first up, I have my acceleration rate. So what this means is every single update, the character is going to get 0.2 pixels faster per update. So that means if it starts at 0 and I'm holding the right arrow key, the next update it's going to be moving at a speed of 0.2 pixels per update. If I'm still holding the right arrow key in the next one, then I'm going to be moving 0.4 and then 0.6. So that means it's adding that much more every single time. It's accelerating. Eventually, it's going to peak out at max speed, though, and that's not going to get any faster than that. So this is how fast your character accelerates, how fast they speed up. Friction is how fast they slow down when you're not running or when you're not moving. And you notice I set it to be half the value of acceleration, which means it slows down half as fast as it speeds up, if that makes sense. Now, why half? Because I just chose it to be. If I wanted it to slow down faster, I would increase this value. If I wanted to slow down slower, I would decrease that value. That would really depend on the surface that I want my character moving on. So maybe this is standard grass, but maybe they're on ice. So I might want them to slow down a lot slower, which means they'll keep sliding farther. It all depends on the game you're making. If they're in mud, I might want them to slow down way faster. I might even have it even faster than acceleration. And then this tolerance value, we'll come back to this, but basically this is used to help us know when to stop moving altogether. But we'll come back to that. So acceleration is how fast I'm moving, I'm getting faster. Friction is how fast I'm slowing down. Okay, let's go down into our load content. Not much here. In the initialize, I'm just setting the screen width and screen height. In load content, I'm just loading my image, which is my flying saucer. I'm setting my location to be at 100 pixels over and sitting directly at the bottom of the screen. So the screen height minus the height of my player. And then my position is just the same as the player rec. Okay, so we have our draw position, we have our true position, and we have our image. But there's no code yet. Where does the code happen? The code happens in load content, of course. So let's take this one movement at a time. First thing I do is I update the keyboard state so I can use this. Now looking at our image, to do forces, we need 3 pieces. Update our speed, so we're going to change how fast we're moving. And then we're going to use the speed update to change our true position. And then we're going to use the true position to change our draw position. So 3 steps. So step number 1, update our speed. Well, we only update our speed if we need to move. So, for example, if I get the right arrow key, I'm going to add acceleration to the player's current speed in the X direction. So if that's 0, then it's going to be at 0.2. If that's 1.3, then it's going to be 1.5 now. So I'm adding acceleration to their current speed, so he's getting faster. It's not its position, it's its speed. And then this line of code here just basically ensures that I never pass max speed. So if you remember way back, we talked about this method called clamp. All clamp does is it forces a value, in this case player speed.x, to be within a specific range. So in this case, -5 and +5. So if, for example, if I accidentally sped up too fast and was at 5.1, this clamp would pull it back down to 5. That's all clamp does, is it forces it within a range. Now this is to make sure that we don't exceed those speed limits. So we hit the right key, we add acceleration to the X speed. If we get the left key, we subtract acceleration to the X speed. So it just just moves in the opposite direction. Well, let me rephrase that. It doesn't move in the opposite direction. It slows down. Okay, so that's why when I'm hitting the right arrow key, if I switch to the left arrow key immediately, it doesn't automatically move left. It has to slow down before it starts moving left. So all we're really doing is reducing the speed. Think of it like that. Not changing the position, reducing the speed. Okay? Now, and then of course we got to keep it within range again. So this will move it. This will speed it up right or left. But what actually applies the friction? That's the else case. What if we're not hitting right or left? That is when we're going to apply friction. So what I do is, first thing I need to know is I need to realize that friction always happens in the opposite direction that we're currently moving. So that's the opposite direction of our speed. So there's my speed. I want to know the opposite direction of that. So I can get the sine of my speed and then just multiply that by -1. So think about this. If I'm moving at a speed of 3.2, the sine of that is going to be a positive. If I multiply that positive by a negative, now I get a value of -3.2. So that gives me the opposite of our speed. Great. Why does that matter? Because now I'm going to take that and then I'm going to multiply that by friction. So remember, friction was half the value of acceleration. So basically we're saying slow down in the opposite direction by the amount of friction. All right, so get the current speed, get its sine. So this is going to be like let's say speed is 3.2. The sine of that is a positive. Multiplied by that one is now going to be a negative. So that -1 times friction. Well, friction is half the speed. So if our speed was 0.2, or sorry, let's look up to friction. Friction is equal to acceleration, which is 0.2 multiplied by 0.5. So that means friction has a value of 0.1. Basically, what this is saying is add a value of -0.1 to our player's speed. So if they're moving in the right, it's going to reduce it. If they're moving to the left, then we're going to add a value of positive 0.1. So then it's going to force it in the opposite direction. Now, this is where things get a little interesting. How do we stop? Because think of it like this. If we're moving to the right and then we say start forcing it left, when does it know when to stop? Well, that's what we're doing here. We're saying if that value of player speed is within a certain tolerance close to 0, then that's close enough. We're just going to force it to 0 at that point. Because we're never actually going to hit exactly 0 because the speeds are fractions of a pixel. We're never going to hit exactly 0. So what we're doing is we're detecting when it's close enough. Now I don't know whether I'm moving in positive or negative direction, so that's why I use math.abs. That will always give me the positive. So let's say the value is 1.5. Is 1.5 less than or equal to the tolerance? If it is, then stop it. But it's not, because let's look at what the tolerance is. The tolerance is 0.9 of friction. Well, friction is 0.1. So that means tolerance is 0.09 in this case. So if our speed is ever less than or equal to that, then we're just going to stop it. It basically means that we're moving even slower than our friction value. So just stop moving altogether. And that's what actually causes that whole thing. So now if we run this, if I move right and let go, it hit that tolerance and it stopped moving. If I go left and let go, again, it hit that tolerance and stopped moving. So all of this from here all the way up to here was part 1, changing the speed. You see, we haven't changed the position at all here. All we did was update its speed, how fast we're moving in a given direction. If we're accelerating or if we are applying friction. And then finally, we have to do part 2 and 3. Part 2 and 3 is just updating its position. So first, update its true position by adding the speed to its current position, and then updating its draw position based on the true position, which is stuff that we've done in movement or in translation the whole time. And that's the entire thing. That's really all you need. I have this extra stuff in here for wall collision just to make sure we don't exceed the boundaries. I'm going to show it to you, but it's not necessary for acceleration, deceleration. It's just for the demo. And all I'm basically doing here in wall collision, I'm saying if I leave the left side of the screen, so if my X value is less than 0, then set my X value to 0. So force it back to 0. And then update the true position as well. And stop moving. Now on the other side of the coin here, I say if my right side is past the screen width, so if I pass the right edge of the screen, then pull it back. Set it exactly in line with the screen width. So screen width minus the width of the player, which is going to put it directly in line with it. And then set the true position and set the horizontal speed to 0. And then we do the same thing for vertical. Again, we're not moving up at this point, but eventually we will. Okay. Now, what if I didn't want to stop movement? What if I wanted it to kind of bounce off the wall? In that case, I could just take that away, or sorry, not that. I could say take the player's speed.x and multiply it. Let's see. Times equals -1. Get rid of that. This basically says reverse the x speed. So what it'll do is it'll bounce off the right-hand wall. So we're going to accelerate and let it go. Oops. And oh, that's the left-hand wall. Sorry, my mistake. See? It just bounces off. Boing. So it depends on the type of game you're making. Maybe that is something you want to do. Let's put that back to the way it was. So this stops movement. So that's acceleration. Everything we need to know. In the next video, what we're going to do is we're going to do jumping, which is really the exact same thing, just in the vertical direction. So let's go to that video and check that one out. Good luck. Have fun.